I'm Takuto Tsukiyama. I'm a graduate school student at Osaka Institute of Technology. Thank you for coming today. I will start my presentation now. The title is Samurai, a transformation system for animation character based on GLCIC, Alleviate the Workload of Animation Directors. I will explain about Japanese animation. Japanese animation has garnered significant acclaim, both domestically and internationally, establishing itself as a cornerstone of Japan's content industry. According to Nikkei explained, approximately 50% of Japanese animation sales are overseas because Japanese animation is esteemed for its meticulous depiction of characters and backgrounds. With this commitment to high quality animation being a prominent factor contributing to its favorable reception. And before explaining the research background, I will talk about the work of animation and directors. It might be less noticeable, but even within the same animation series, the artistic style of characters can vary slightly from one episode to another. The reason for this is that each episode has an animation director. Animation directors are responsible for unifying the style of the entire animation. So, in the figure, the animation director checks the key images sent by the key animators and, if necessary, request modifies from them. On the other hand, there are cases where animation directors modify to the key images by self without requesting the key animators to modify. But due to the increasing number of animation titles, there is a relative shortage of animators. According to data released by the Japan Animation Creators Association, although there have been periods of decline, the overall trend shows a yearly increase. In 2021, the number of animation titles reached 310, and during its peak in 2016, there were 361 titles. This represents an increase of 40 to 50 times compared to 1963. Additionally, when it comes to the number of frames, for TV animation, it ranges from 3,000 to 5,000 frames per episode, and with tight deadlines. For animation films, the workload exceeds 10,000 frames. As a result, the burden on animators is extremely heavy, leading to situations where deadlines cannot be met. Furthermore, the shortage of animators is also impacting animator education. According to the 2019 animation production survey report, a person with inferior technical skill is working as character designer and chief animation director. And animators' technical skills are several degrees. So this suggests that animators may become animation directors without having sufficient skills. So, uh, so my research purpose, we will development a system to reduce the workload of animation directors. I will explain on the related research. There, there have been several research efforts aimed at addressing the challenges in the animation industry. One is illustration failure detection based on this correspondence in animation production process. When there are two consecutive images, the system compares pixels at the same location, and if the values are significantly different, that pixel is recognized as incorrect. Conventionally, error, error detection has been performed manually, so errors may be overlooked. However, by using this system, users are less likely to overlook errors. Other is animated drawing, animation portrait exploration during your sketching. When this system, when the user draws a sketch, the system displays a rendering of the animated images. This allows even beginners of illustration to create high quality animation images from simple sketches. To address the research challenge problems explained earlier, this research developed Samurai, supportive artistic masterpiece uniting real-time AI. It has a function to modify a part of images and is aimed to reduce the workload on the animation directors. I will explain the modify part of an image. Please watch the video. Press the File button in the top left corner to select the image users want to modify. Next, click the Pen button to fill in the areas users want to modify. Afterward, users press the Save the Mask layer button to save the layer. Finally, users click on the image of style collection button and areas. I will explain the algorithm of this system. First, the system converts the image of drawn strokes by the users into the mask image. So, next, the system uses the mask image to miss the input image. Finally, the system predicts from the, sorry. Next, the system uses the mask images to miss the input image. Finally, the system predicts from the trained model and outputs the modified image. By the way, this trained model is using GLCIC. I will explain the GLCIC used in this system. GLCIC is a machine learning technique implemented by Izuka to explain, consider a male face image. When a image with a missing part is presented, GLCIC compares it with the surrounding pixel information and deconstructs the image while ensuring a seamless restoration to avoid perceptual discrepancies. GLCIC can also erase object image. In that case, the users can fill in the object they want to erase, and the system can erase the object and generate a natural looking image. We make a data set for each animation working of the animation directors. This time, we made a data set for each animation work of the anime. This time, we made a data set of work directed by animation director S. We collected a total of 75 character images and focused only on characters, facial images. However, these images are colored. Therefore, we used an application that convert them to the line drawing to generate image data with only lines. Also, since 75 images is not enough, we increased the number of 1,500 for each image. Setup is mask size of 48 pixel time 96 pixel, and batch size is 16. The epoch is 400,000. Running results are shown in this image. Look at the eye part of image. The images are from the 319,000, the epochs, and the 400,000 epochs. The system was able to convert the eye painting style correctly. But for the 390,000 result, the system has converted the closed eye part to an open eye. This conversion occurred because the training data for this study were real images with open eyes. I will talk about experiment with our system. In this experiment, we asked male illustrators in their teens and 20s to use our system. They completed the 5-point questionnaire after experiencing the system. The move shows the scenes of this experiment. This is the content of the questionnaire. The first question is, does this system reduce work time? The second question is, does this system make it easier to modify the key images? Third question is this too easy to operate? The fourth question is the UI of this system good? The fifth question is, did you enjoy this system? The sixth question is any feedback on this system? I show the experiment result in the table. 1 is a bad point and 5 is a good point. Question number 1 is a relatively good good evaluation. But questions number 2 and number 3 is not a very good evaluation. Positive opinions is this system is likely to lead to a reduction in not only time but also cost. And I enjoyed it when the painting style changes. Negative opinion is this system has small text on the buttons and is difficult to read. And I feel this system has a lot to do. We will discuss the consideration of this result. The negative opinions concerning user experience and user interface can be ascribed to the two-step process required for users to make alteration to the key images. This means that it can only be modified by pressing the image of style correction button after pressing the save the mask layer button. I think that users gave negative feedback because they found this two-step process to be a hassle. We conducted a keystroke level model analysis to statistically analyze the opinions we received. Keystroke level model is a method that counts the amount of time it takes for a user to click a mouse or press a key to complete a specific operation and calculate the total time. K is keystroke or button press. P is pointing with a mouse. And H is homing the hands on the keyboard or other device. D is draw time or N line of length I. M is mental preparation. R is response time. This is a result of a keystroke level model analysis. The current system has a mouse pointing time and key press time 4 times each and takes 5.2 second. On the other hand, by improving the system, mouse pointing time and key press time only need to be performed once, which shortens the time to 1.3 seconds. In other words, there is a 4 times difference. If the functions are integrated, it is expected that the work will be reduced by a quarter. I will explain the second proposed method. This is what I did after writing my thesis. When I participated in Japan Society for Animation studies, I received the following opinion from an expert in the animation industry. One male opinion is I feel that it is difficult to solve the problem by modifying a part of the image. Would you not it be better if you could modify the entire image at once? So we implemented the function to modify the entire image with our system. I will explain the function to modify the entire image. This utilizes techniques similar to pattern matching. First, the system places an n pixel time n pixel mask at the top left of the image and modifies the area within the mask. Next, the system slides the mask to the right by an amount equal to the mask size and modifies the area within the mask. Ultimately, the system repeats the process all the way to the bottom right of the image, modifying the entire image. I will explain the second experiment. This experiment consisted of three stages: pre-questionnaire, drawing the key images, and post-questionnaire. Additionally, the post-questionnaire consisted of three stages. I will explain the pre-questionnaire. 5 illustrators participate in this pre-questionnaire. The contents of the questionnaire are as follows. One is periods of painting. Second is number of illustrations drawn per month. Finally, media used for drawing. Will explain drawing the key images. 5 illustrators copied the characters from the images presented by the author. The copied image was input into Samurai, and the image was modified. I will talk about the first post questionnaire. This questionnaire evaluates whether the images output by the system we developed resemble the style of the training data. In addition to the 5 illustrators who participate earlier, we also had 15 non-painters to take part in this questionnaire. Images A to E are key images drawn by each participant that were modified by the samurai. I will talk about the second post-questionnaire. In this questionnaire, 5 illustrators were asked to watch a video of how samurai was operated and evaluate each item regarding our samurai. I will talk about the third post-questionnaire. In this past questionnaire, we asked 5 illustrators about what they noticed when they looked at the key images that has been modified by the system. Specifically, when they see the revised key images, they evaluate whether they notice where has been revised and where should be revised. Images on A to E. Left is images before modification. Right is images after modification. This is a result of a questionnaire on the reproduction of the painting style. key image B, D, and E had many things, many rating of 4 or of a high rating higher. Most people gave key image C as of 2 or lower. Here is the discussion of questionnaire on the reproduction of the painting style. Participants gave opinion about images B, D, and E, such as outlines are similar, and the atmosphere is similar. Participants gave opinions about image C, such as I see a different style of painting overall, and the face is crushed. The reason for this result may be that when the system modifies the image, it leaves too much of the artist's grace. We analyzed this result using a T-square test. As a result, the p-value for all images exceed 0.05 and no significant difference was found. This revealed that there was a bias in the evaluation of all images. This is a result of a questionnaire about samurai. 1 is a bad point and 5 is a good point. All people evaluate the systems operate as 4 or higher. Additionally, 4 people evaluate the systems ease or use as a 4 or higher. This is a result of a questionnaire about the awareness of the modified key image. 1 is a bad point, 5 is a good point. Participant A's evaluation falls while participant B's evaluation are all ones. This result shows that each subject has different preferences. We conducted an analysis of the questionnaire about samurai and the questionnaire about the awareness of the modified key image. The 3 of conducted a semantic analysis of the opinions we received in the free form. We divide them into positive and negative opinions and extracted the most common keywords. Here are the opinions classified as positive in the semantic analysis. It could be broadly divided into 3 words: time, image, and system. Here, the opinion classified as negative in the semantic analysis. This could also be classified in the same way as positive: system, time, image. Here is the discussion of semantic analysis. Among the positive opinions, there were many words related to the proposed system, among which was related to operation, such as easy to operate and simple. Words are most common. Negative, on the other hand, negative opinions included many words related to images, among which was related to image quality, such as poor quality and grainy, was the most common. There were many words related to time, such as the amount of time it takes to make modification. These causes include insufficient type of training data and the number of epochs was a mask size 5 pixel times 5 pixel. It's too small compared to the image size 300 pixel times 300 pixels. We discussed the conclusions of this research. The purpose of this research is to develop a system that reduces the workload of animation directors. As for whether this goal has been achieved, I think it has been partially achieved. Before improving the system, participants gave raw evaluations to the user interface and system operations. After improving the system, participants gave positive comments such as the user interface is easy to understand and the operation is simple. But there are still issues with this system, such as long modification times and poor image quality. So I concluded that it has not fully achieved its purpose. This is a summary slide. This is the end of my presentation. Thank you very much for your attention.